Welcome to the forced RLC circuit video. In exercise 1, we'll be measuring the internal resistance and the damping coefficient of the LC circuit.
First, we'll set up the RLC circuit. Use a T connector on the function generator so that we can view its output on the oscilloscope as well as send it to the circuit. Using a BNC to banana adapter, connect one pin to the inductor. Connect the other end of the inductor to the resistance box. Connect the other end of the T connector to the oscilloscope. Use the second BNC to banana adapter on channel 2 of the oscilloscope. Connect the ground pin, the metal one, to the ground pin of the function generator. Note that your circuit will not function properly if this order isn't adhered to. Connect the capacitor to the other function generator terminal. Connect the other oscilloscope pin to the remaining terminal of the resistance box and add the other capacitor wire here to complete the circuit.
Next, we'll verify that our circuit is working properly. Begin by adjusting the oscilloscope channel levels and timescale so that you can see a signal. Ensure that the function generator is putting out a square wave at a frequency significantly lower than the natural frequency of your circuit. If all goes well, you should see an oscillatory signal that is high in amplitude when the square wave switches, but rapidly decays.
Add a wire to short out the resistance box. Ensure that your oscilloscope channel levels and timescale are set appropriately. Insert your USB drive and press recall/save. Ensure that action is set to save all and press the save button. Note that these oscilloscopes will take some time to save your data.
In exercise 2, we'll be constructing amplitude and phase spectra for a driven RLC circuit in order to come up with the new estimates for the natural frequency and damping coefficients and compare them with those found in exercise 1.
Remove the wire shorting the resistance box and choose a resistance to work with. If using Data Studio, make sure the voltage doesn't saturate at resonance.
Change the function generator to output a sine wave. Adjust the oscilloscope such that you can see the RLC circuit's output only. Sweep through a wide range of frequencies and observe the effect on the amplitude. If the voltage is saturating at a resonance, try adjusting the resistance.
Set the frequency below resonance. We will measure the phase and amplitude at this frequency. To measure the amplitude, you can press Measure and set one of the slots to channel 2 peak to peak. Alternatively, you can press Cursor, set the type to amplitude, set the two cursor levels appropriately, and read the delta from the display. To measure the phase, display both channels. Set the horizontal scale widely, and place a cursor at the zero crossing of each wave. Note that the phase difference at low frequencies will be very small. Increase the frequency and repeat, mapping out phase and amplitude as a function of frequency. The curve is non-linear, so take more data near resonance.
Entropy isn't what it used to be.